Hi guys, I know a lot of you have been asking questions about how do we represent lines with equations and what does it even mean to represent a line with an equation? And that's a tough concept to start to wrap your head around. I understand. So I'm going to try to explain with an example that you guys really know a lot about already. I wrote down this equation. It's C equals 2 times pi times r. Now, you might not use the word equation when you see that one. You might say, that's the formula for circumference if you know the radius of a circle. And you're exactly right. So an equation for a line is like a formula for calculating one value when you know another one, right? We can represent the circumference of a circle by its relationship to the radius of the circle. The circumference is always 2 times pi times the radius of that circle. Now, is that a linear relationship? I don't know, let's investigate it a little bit. We like to represent relationships in 4 different ways when we can. We like to try to write a formula or equation for the relationship. We like to represent the relationship in words. So we know this relationship in words. One way to put it would be to say the circumference of a circle is twice the radius times pi, or 2 pi r. We can use the formula to calculate out different size circles, right? If I tell you the radius, then you can calculate the length of the circumference. So if I was to say, what's the circumference of a circle that has radius of, let's just say, 1? Then you can use this formula to calculate what the circumference would be, and it would be 2 times pi times 1. Or roughly 6.28. And we could calculate other points. What if the circle had a radius of 2? Then it would be 2 times pi times 2, which, if math is good to me, is 12.56. What if it had a radius of, you could pick any number. What if it had a radius of 25? Then it would be 2 times 3.14 times 25 for the circumference. And I haven't worked that out. You can just punch that in your calculator and figure it out. Right? Now, what would happen if I was to take all these different radius and circumference measurements that match up with each other and put them onto a graph? We would get something that looks a little bit like this. We're going to call the radius the independent variable. I choose the radius of the circle, and that sets what the circumference is for me. Right? When I decide the radius, I don't have any choice anymore about what the circumference is. The circumference is calculated by the radius. So if I have a radius of 0, there's really no circle, so it would have a circumference of 0. If I have a radius of 1, I have a circumference of 6. So let's say that's 1, not 6, 6.28, blah, blah, blah. Right? If I have a radius of 2, I get a circumference of 12.56. So about twice as high again. And if I keep plotting all these points, I find different radiuses and different circumferences that all match up with each other and come out in a nice straight line. I can keep finding as many different radiuses and as many different circumferences as I want, and they all match up in this nice straight line, always perfectly straight line. I can't really draw an infinite number of points, but what I do on my graph is I connect all these points with a nice straight line to represent in my head for myself that you could pick any radius. Look on the line, find the point that matches on the line, and that will be the circumference. Right? So what a graph is saying that there's every possible radius, and we could find the circumference that matches that radius. Okay, why do we call this a linear relationship? Because all those radius points and circumference points match up and form a straight line when we graph them. So that's what makes it linear. Right? So there we have a linear relationship being represented by a graph, by a table of values. Well, we can calculate any point we want on the table of values. And how do we calculate those points? We use the formula or equation for the linear relationship. I hope that helps a little bit on understanding what we mean when we say we represent a linear relationship with a graph to get a picture of it, a table of values to calculate a whole bunch of different points, a formula that allows us to calculate any particular point, and a description in words so we know what we're talking about.